This call is now being recorded.
First and a simple question. For 4 symbol input, the LMS algorithm require dash operation per iteration. This is the question you need to answer out of the 4 options A, B, C, D. If you know this question, you can answer the question. Do anyone know what is LMS algorithm? Full form of LMS? See, LMS is least mean square algorithm. This type of algorithm are mainly used in the receiver side along with the equalizer to remove the error or to reduce the error in the receiver side. The error that are caused in the channels due to the turbulence, fog, or anything, these errors are reduced by equalizer with LMS or LMS or RLS or zero forcing algorithm. This type of algorithm are used to reduce the error. So let me make a simple block diagram. For example, in the receiver, after the filters, you have this ZM of signal. Now this signal will be given to equalizer. This, let's take it the output of the equalizer of SYM. Here we will have LMS algorithm. Known data stream. In this output of the LMS algorithm will be given to equalizer QL of M. So it's a kind of feedback technology that is predicting the error that may cause in the next output and predict the what is going to be the next M+1 outputs. So this is how this uh, LMS algorithm works, and this is how this reduces the error. I am not going into the detail of this algorithm. I am just giving you the overview what this algorithm do and what is the working of this algorithm. I am not going into the detail of the algorithm that you can read from your reference book. There are generally 3 kinds of algorithm generally that are used. First up is LMS, second is RLS, recursive least square, recursive least square. If you want to read in detail, you can read from the references book. And zero forcing algorithm. So these are like general algorithm that are used along with equalizer to reduce the error that are caused in the channels. I hope it is clear. So, and the question is, how many for 4 symbol the operations that are required. So here the operation is like if there are n symbols, if there are n symbols, then the operation that is required is 2n plus 1. If there are n symbol, then the operation that will be required is 2n plus 1. So here, can you tell the operations per iteration that will be required is 9. Obviously, 4 plus 1, 2 into, and n is 4 plus 1, that will be 9. So 9 is the correct answer. Let's move to the next question. Consider a MIMO system with 2 transmitter and 3 receiver antenna. Sorry, this is receive antenna. What is the dimension of the channel matrix? Option are A, B, C, D. Consider a MIMO system with 2 transmit antenna and 3 receive antenna. What is the dimension of the channel matrix? Yeah, Gitansh, you have given the correct answer only. Anyone else? See, the received signal Y is H into X, where H is channel matrix. So H will be like, if suppose you have 2 transmit antenna, then it will be like T1, T2. Similarly, T1, T2. So the matrix that will be there, this, let me make a diagram. Suppose you have 2 transmit antenna and 3 receive antenna. So this 1 and 2 will transmit its signal to all of the 3. 1, 1, and this. Similarly, this will be also transmit to all of it. 1, 2, 3. So 1 to 1, like, and second to 1. Similarly, 1 to 2, 2, and 1, 3, 2, 3. So here we can see that there are 3 rows and 2 columns. 3 rows and 2 columns. So the order will be 3 cross 2. The answer is 3 into 2. Let's move to the next question. In a VLC system that uses a zero forcing receiver, the channel matrix can be made well conditioned by following the photo detector receiver structure. Do anyone want to anyone have the answer of this question? Single photodiode receiver with wider field of view. Obviously, as it is taught in the class, that the multiple receiver will improve the performance of the VLC system. So there you can say that multiple photo detector. Now, depending on the condition algorithm, if you vary the field of view, then it will improve your performance. From here, you can get this answer. If you have taken the classes by Anand sir, then you can easily answer this question in C part only. In a VLC MIMO system, the channel between a given transmitter and two closely placed receiver with the same orientation will be different and random, similar and deterministic, and similar and random, different and deterministic. Four option A, B, C, D. Please answer. I will wait for some time for you to answer this question. This is a easy question. I hope you all can answer this question. Let's first figure out will that be a random signal or a deterministic type of signal? Do anyone want to answer this? See, in the second part, we have only two options, random or deterministic. Someone is answering B, someone is answering D. See, let's assume a transmitter here, TX, and the two closely placed receiver. It is a indoor channel. Uh, so both of you answered that it should be deterministic. Why deterministic? Why not a random one channel? Ramandeep, would you like to answer why it should be a deterministic? Why not it should be a random? Kalyan, would you like to answer this question?
I'm not sure. So because of his close proximity.
No, no. See, if we are talking about the channel, then channel is here in between the transmitter and the receiver. So it's not due to the close proximity. Um, See, it's we are talking about the indoor channel, you know. So generally in indoor we know the conditions, what is there in the ambient light and all that. So in indoor system we generally know the uh, channel. We know how much is the light, and the situation remains generally same only. So due to this, the system is deterministic. If it be an outdoor channel, then we don't know that there may be a rain, fog, or there may be a turbulence. This keep on changing randomly. So in the outdoor, it is a random. If we talk about the outdoor channel, it is a random one. But if you take it as an indoor channel, it is generally a deterministic one. And as these are placed very close to each other, so this will be a similar and deterministic. In an optical wireless channel, uh, the temporal dispersion caused by the multipath is characterized by Yeah, correct answer only. This is transmitter and this is the receiver. Can anyone tell me what is temporal dispersion? Uh, Kalyan, can you tell me what is temporal dispersion?
Yes, sir. This is signal delay due to as a signal follow the two different part, so it can causes delay. That is
Yeah. Temporal dispersion is delay in signal because the signal follow the multipath signal, multipath channel. See, this is a line of sight, and the signal may also come from the line of sight. This is non-line of sight, or the signal may come like this way. So it's also a non-line of sight. So the signal that is coming from the non-line of sight path, so this is path 1, this is path 2, this is path 3. They have delay with respect to the part 2 and 3. So this delay can be characterized by tau RMS and tau mean. I have also taken a numerical on this delay and all that. We will discuss this in the later part of this section. Basically, temporal dispersion is delay caused by the multipath of signal. So this is also called as delay split. A good optical MIMO receiver for indoor optical wireless application should have these characteristics. Option A, B, C, and D. Yeah, correct answer only. C. Uh, First, it should have a large overall field of view so that it has a line of sight to as many luminance as possible, and it should have a compact structure compatible with the incorporating in portable devices. So these two are the correct answer only. So both A and B will be the correct answers. Uh, Next, I have kept a small video. This video is made by my juniors on visible light communication. In the last class, I have demonstrated a video on visible light communication. There, I have used laser. Now, in this video that I will be showing in the next slides, there we will be using LED. So the rest part of the video will be same only, but in place of laser, we will be using LED. This video was made by my juniors, and this video is in Hindi only. So I hope you will get to understand. If you don't understand anything, you can ask me after the video.
I use following component. This is a breadboard, speaker, solar panel, several aux cables, one watt LED, few wires, and the laptop for the input. ये जा रहे हैं input circuit. तो हम लोगों ने पहले यहाँ पे resistance को connect किया, फिर हम लोगों ने LED लिया जिसमें उसके लेफ्ट और राइट मतलब उसके नेगेटिव और पॉजिटिव का कनेक्शन कर चुके हैं हम। तो उसके पॉजिटिव को हम लोग रेजिस्टेंस से कनेक्ट कर दिए, उसके नेगेटिव को ब्रेडबोर्ड में एक खाली स्लॉट पे डाल दिया ताकि उसको ग्राउंड दे पाए हम लोग। फिर हम लोगों ने ऑक्स केबल लिया, ऑक्स केबल में ये ऊपर वाला हमारा होता है लेफ्ट और राइट और नीचे वाला होता है ग्राउंड। सो हम लोगों ने उस हिसाब से एक कनेक्शन बनाई जो आप ये देख सकते हो। इसके लेफ्ट और राइट से भी एक कनेक्शन निकाला और इसके ग्राउंड से भी एक कनेक्शन निकाला। हम लोगों ने एक पॉजिटिव सप्लाई लिया है जो हमारे इस पावर सप्लाई से आ रहा है और एक नेगेटिव लिया है, तो हमने इस पॉजिटिव को रेजिस्टेंस को दे दिया एंड इस ऑक्स केबल के ग्राउंड को हम लोगों ने एलईडी के नेगेटिव पे डाल दिया एंड इसके लेफ्ट राइट को हम लोग पॉजिटिव से जोड़ देंगे, नेगेटिव से जोड़ देंगे। तो ये हमारा पूरा इनपुट सर्किटरी का कनेक्शन हुआ। हमारा आउटपुट सर्किटरी, ये हमारा सोलर पैनल है, इसका पॉजिटिव नेगेटिव। तो इस सोलर के पॉजिटिव को हमने इसको यहाँ पे राइट पे कनेक्ट कर दिया, नेगेटिव को इसी लेंथ पे कनेक्ट कर दिया। अब हम क्या करेंगे, ये क्या इसका लेफ्ट राइट है और ये इसका ग्राउंड है, तो ये हमने इसका ग्राउंड को इसके नेगेटिव पे कनेक्ट कर देंगे और ये इसका लेफ्ट राइट है तो इसके पॉजिटिव पे दे देंगे। ये कनेक्ट कर दिया, ये देख के बाद इसको सब सीधा है उसको इसको जो हमारा आउटपुट डिवाइस है सीपीयू उससे कनेक्ट करते हैं। इसे हमने कनेक्ट किया, ये हम पर स्टार्ट हो गया मतलब कि दिस सर्किट इज वर्किंग। हम लोग का पूरा सर्किटरी है, यहाँ पे देख सकते हैं आप, ये आउटपुट सर्किट है और ये इनपुट सर्किट है और हम लोग इनपुट देंगे इस लैपटॉप के द्वारा जिसमें हम लोगों ने सॉन्ग बजा रखा है। हम लोग जैसे ही गाना स्टार्ट करेंगे आप देख सकते हैं एलईडी ऑन हो चुका है and we are getting the output. This is not लगा दे, ये बंद हो गया मतलब ये लाइव चल रहा है। ये जो हमारा हम लोग देखने जा रहे हैं कि ये वर्किंग है, ये हमारा प्रोजेक्ट अभी ऑफ कंडीशन में है, मतलब एलईडी आप देख सकते हो यहाँ पे ऑफ। अब हम लोग जैसे ही ऑडियो ऑन किए एलईडी ऑन हो गया। ठीक है, यहाँ पे देख सकते हो आपको ऑडियो आवाज आ रहा है और जैसे ही इसको डिस्टेंस बढ़ा रहे हैं, जैसे ही एलईडी से हमारा रिसीवर का डिस्टेंस बढ़ रहा है उस तरह से वेरी कर रहा है साउंड।
I hope everyone have got the video and understand everything that have been seen in the video. If anyone have any doubt regarding this video, you can ask me.
How practical is this for use in place of Wi-Fi?
Yeah, this may be used in place of Wi-Fi. As of now, it is not being as used as an alternative Wi-Fi, but in coming times, it may be used in alternative Wi-Fi. It have some advantages as compared to Wi-Fi, and at the same time, it have some disadvantages as compared to Wi-Fi. Advantages in terms of speed is there, data rate is there, security is there. These are the advantages. If you talk about the disadvantages, it require line of sight communication. If someone comes in front of the receiver, then the signal will be not be passed. So I don't have much idea that it is being commercially or anything. It is used somewhere in the practical applications, but in research this have been demonstrated, and this is surely in coming times Wi-Fi will be used in some places where Wi-Fi is being used. I hope I have answered your question.
Yes.
Okay, thank you. Anyone else and want to ask anything? These videos are also available in the YouTube also, so you can, if you want to see afterwards, or if you want to make your own circuit, you can see this video and make it. So okay, let's move to the next question. Uh, in optical channel gain, following the Lambertian radiation pattern, the optical filter gain and the concentrator gain is a function of. So this is our receiver. This have a field of view. So this, the concentrator or optical filter that are used in the receiver side, so that more of the light is focused here in the receiver, in this in the receiver, and it comes in the field of view of the receiver. So light comes in the field of view of the receiver. So it also depends on the what is the field of view of the receiver. So the answer will be C. Yeah, sorry. Yeah. Answer will be C. Receiver field of view. Let's move to the next question. In a VLC MIMO system, diversity is achieved using option A, B, or C or D. Okay. The answer is C. So let's try to understand what is diversity here and how many types of diversity are there. Diversity can be a spatial diversity. It can be a time diversity. It can be a frequency diversity. What is the difference between this spatial time and frequency diversity? Can anyone would like to answer this question?
Frequency
In a
diversity.
spatial,
Sorry.
Uh, Anyone of you answer the question?
in spatial diversity, we use more than one source or more than one receiver for same signal. Or in time diversity, we use the same signal at a different time duration, or in a different, you can say, like in TDMA we use. And in frequency diversity, the multiple sources have multiple this frequency, different frequency.
Okay. Uh, Anyone else would like to answer? Yeah, answer is correct, but it is. I want to hear more like precise answer. Someone else was also answering the question. Okay. In space diversity, you have in space you have different transmitter and receiver. These are in the space. Whereas in time diversity, you don't have like multiple receiver, but at different time you send different signal. In frequency diversity, at different frequency you send different signal. Rest all are same. Here different receiver, different transmitter are transmitting different signal in space. In space, that's why the name is space. Here it is time diversity. At different time you send different signal. At frequency diversity, at different frequency you send different signal. So these are the three types of diversity. Other than this, there may be a field of view diversity. You change the field of, you have different field of view for the receivers, and there may be a diversity in field of view diversity. So there may be a many kind of diversity. But basically, in general, we talk about the three kind of diversity: spatial, time, and frequency diversity.
Out of these three, which is more common, or you can say which is more effective?
Spatial diversity is more common and it's more in use.
Okay.
Let's move to, now. See, if we talk about the spatial diversity, as I have told that there will be a multiple transmitter and there will be a multiple receivers. Let's say this is antenna 1, 2, 3. These are antenna. This receives the signal. Here we have a gain G1, G2, Z3. Switching unit logic, or this may be a like of decoder, and here we will have the output. Now this received, all this received signal can be given to a equal gain. See, if like this received signal, whatever the signal is received here, this will be multiplied by G1, second G2 and G3. And if the value of G1, G2 and G3 are same, G1, G2 and G3 are same, then this kind of combining technique is known as equal gain combining technique, where all the gain of the of individual receiver are same. This is known as equal gain combiner. Combining all the signal in co-phase manner with unity gain, unity or equal, for all the signal levels so as to achieve highest SNR at the receiver at all times. So this is equal gain combiner technique. Now, next is maximum ratio combining. Here, what you do, you change the gain of individual receiver. G1, G2, G3 all have different values. So you keep the value of G1, G2, G3 so as to maximize the SNR. You change the value of G1, G2, G3 so as to maximize the SNR. This kind of receiving technique is known as maximum ratio combining principle. Combining all signal in co-phased and weighted manner. Weighted means G1, G2, these are weighted differently so as to have the highest achievable SNR at the receiver. Second is, next one is selection diversity principle. Here what we do, we select the best one out of all of this. We receive all the signal, but we select the best one out of all of this. So selecting the best among all these signals received from different branches at the receiver end. So this is what selection, from the name you can identify the selection diversity principle, maximum ratio combining principle, equal gain combining principle, and next diversity technique, what I was telling about time diversity principle, the signal represent the same information and sent over the same channel at different times. Next, solve a small numerical here. The power delay profile of a channel is given like this. Now you need to calculate the mean delay is given as you have 4 options. You need to use a pen and paper and calculate it. You know, I will wait for some time for you to calculate the answers, and then I will give the answer. The mean delay. So there are 4 signals: 1, 2, 3, 4, 5. So what will be the mean delay? And so only one thing in this part, I am also only about the mean delay. There are 5 signals: 1, 2, 3, 4, 5. So I am writing I equal to 1, 2, 5 tau I. P is the power, T is the tau I is the delay. Can put the value of tau and P. So let's say this is P1. So the value of the P1 will be minus 7 dB. If you convert the dB into normal scale, then it will be 10 raised to power minus 7 by 10. Is it correct? Minus 7 dB in normal scale, it will be 10 raised to power minus 7 by 10. Yeah, see, I think power delay was covered in week 3 or 4, somewhere like that. The power delay profile was created maybe week 3 only, week 3 or 4. It was somewhere there. I know sir have taught this power delay profile in week 3 and week 4 somewhere. There was, it was there in the class. It was in week 3 or week 4. So it's not that we are learning only for this week only. No. In the diversity part was taught in the week 4 only. Gitansh, the diversity was taught in week 4 only. Sir have taken the MIMO section, no? In MIMO, sir have taught about the diversity in week 4. Although it was not taught in the class in very much detailed way, but it was there in the class. Let's solve this question. Diversity was taught in the class, but it was not in much detailed way. Sir didn't told it in a detailed way. So power P2 will be, correct me if I write anything wrong, 10 raised to power minus 5 by 10. This will be 10 raised to power minus 0 by 10. 10 raised to power minus 6 by 10. And this will be 10 raised to power minus 9 by 10. So these are the corresponding powers in normal scales. So tau bar. So if you, and tau is 2 nanosecond, 2, 3, 5, 8, and 9. So if you put the value of tau and p here in this equation, you will get the mean delay. So mean delay is 2 nanoseconds. So I am writing, in place of 2 nanoseconds, I am writing just 2 into delay is 10 raised to power is 10 raised to power minus 7 by 10 plus 3 into 10 raised to power minus 5 by 10, 5 into 10 raised to power 0 by 10 plus. Do anyone of you have got the answer? 8 into 8 into 10 raised to power minus 6 by 10 plus 9 into 10 raised to power minus 9 by 10 divided by power, summation of power. 10 raised to power minus 7 by 10 plus 10 raised to power minus 5 by 10, 10 raised to power 0 by 10, you try to solve this part. Once you solve this, I will give the answer. If any one of you get the answer, you can write here in the comment box, or you can also say the answer. So if you solve this part, you will get 9.49. This is in all are in nanoseconds only, no? Divided by 1.893 nanoseconds. So if you solve this, we'll get answer as 5.01 nanoseconds. I hope you have got the answer. Next question is similar to this question only. There you need to find the RMS delay spread in the previous problem that we have solved. You have again the 4 option A, B, C, D. In this question only, you need to find the RMS delay spread. And you have 4 option A, B, C, D. You try it yourself, then I will answer this question. So formula for the RMS delay is tau RMS is given by sigma I equal to 1 to 5 tau I minus tau bar. This tau bar is mean delay spread that we have calculated in the previous section, whole square T I divided by, sorry, this divide is this divided by sigma Pi. So if you put the value of tau bar that we have calculated in the previous section, P and Pi, will get the answer. Let's try this out. Under root tau I is 2 nanoseconds. So 2 minus 5.01 whole square into Pi. So the Pi was 10 raised to power minus 7 by 10 plus next delay was 3 minus 5.01 whole square into 10 raised to power minus 5 by 10 third 5 minus 5.01 whole square into 10 raised to power 0 by 10 plus 8 minus 5.01 6 by 10 plus 9 minus 5.01 into 10 raised to power minus 9 by 10 upon sigma Pi. You remember sigma Pi, which is in the previous section we have got it as 1.893. You solve this. Do anyone of you have got the answer? The answer is 1.968. Yeah, correct only. 968 nanoseconds. B. B is the correct answer. This numerical was related to the RMS delay spread. This is basically the temporal delay spread that we have discussed in our problem number 2 or 3, somewhere like there. So we have done a numerical on this. And this is the last problem, problem number 11. This problem was asked in the UPSC civil service exam prelims 2020. So this question is very interesting and simple, and this question is related to visible light communication. That's why I have taken this question here. Everyone, if you read this question, I hope you will be able to answer this question. You need to answer. Option is A, B, C, or D. Let's read out the question. With reference to visible light communication technology, which of the following statement are correct? First, the VLC uses electromagnetic spectrum between 375 to 780 nanometers. VLC is known as long range optical wireless communication. Third, VLC can transmit large amount of data faster than Bluetooth. And fourth, VLC has no electromagnetic interference. Yeah, someone have given the answer, and that is correct only. As you know, the visible light spectrum is between somewhere 375 to 780 nanometers. So obviously, this one is correct only. If we talk about the option number 3, the VLC can transmit large amount of data faster than Bluetooth. Yes, can transmit a larger amount of data faster than Bluetooth. We have seen that it can transmit data in Gbps, Mbps. It have a no electromagnetic interference. This is also correct. But this one option, it is known as long range optical wireless communication. It's not correct. Can anyone tell for long range optical wireless communication, which frequency is generally used? Can anyone answer? FSO, free space optical communication. Yes, sir.
1550.
Yeah, correct only. 1550, 15 nanometers. It is because it have very less amount of attenuation in the atmosphere and also in optical fiber. And the second reason why this frequency is used is because ability of component. See, the component that are designed for free space optical component that are very much available in particular frequency or particular wavelengths, like 1550 nanometers or 1310 nanometers or 850 nanometers. So these two reasons are the main why we use this particular frequencies only for long distance communications. So this is the reason why we use 1550 nanometer, and VLC is generally used for the indoor communication or vehicle to vehicle communication, where short range of communication is required. Either it may be vehicle to vehicle or indoor or any in a hall. So for generally VLC is known for short distance of communication. That is it, and obviously C option is correct. So for today, that's it from my side. And if anyone have any doubt or query or wants to ask anything, I will take up the question, and after that I will end this session.
Sir, I have another question regarding FSO. Do we use any kind of simulator for FSO link budget planning?
I am here working in FSO only, free space optical fiber communication technology. Generally, you can use a MATLAB codes to to perform your simulations that we have been doing. And other than that, we have a hardware system in our lab. Hopefully, in the next week, I will show you my hardware setup if possible. So we have a hardware setup of FSO FC communication, free space optical fiber converged communication. So I have a hardware setup in my lab. So I generally work in this hardware setup. I calculate the losses that are caused in the hardware, or also we do MATLAB simulations also to see the if in simulation how the system performs. But I'm not able to get get the question what you are asking for link budget. What calculation you are talking about?
Yes, suppose what are the receive levels required at receiver level and for a FSO links, how it will perform, how to predict the eye diagram, what will be the errors will come in case of turbulence or scattering, all such a simulation. Is there any tool available?
Yeah, you can do this using MATLAB. There is also a tool, OptiSim simulator tool. Here you can place like components and all that, and you can calculate the errors. In YouTube also there are some videos are available regarding this OptiSim. If you put this in YouTube videos on OptiSim, you will get it. But I personally have not used this OptiSim simulators, so I don't have much idea about the OptiSim. In MATLAB you can do, but in MATLAB you will not be able to get the eye diagrams and all that. MATLABs are basically used to solve the equations. So you can get the BER or average BER plots and capacity and all that plots you can get in MATLAB. But if you want to see the eye diagram and all that, I think that facility is not available in the MATLAB. Either you can do it by hardware. If you have eye diagram is generally seen in the oscilloscope. No? So eye diagram, and there are devices are there, bit error tester and bit. In our lab we have bit error tester, BERT. Hopefully I will show you my lab in the next week. So this is used to test the bit, and oscillator is used to show the eye diagram. In simulator, OptiSim is there, but I have not used this OptiSim, so I will not be able to actually tell how efficient or how what are the performance metrics it have. But up to you can explore this. The videos are available in the YouTube. This is up to some extent. This is good for FSO communication.
Sir, another query. Suppose we are planning 1 kilometer FSO links. So in that case, we have to determine the laser power and as well as the far end receive levels. So I hope I can clarify my questions better now.
You are telling that you want to make a link length of 1 kilometer. So what is the amount of laser power that is required to transmit? Is this your question?
And also the receive level. So what will be the required receive level? Because we have to align properly without any pointing loss, right, sir?
Yes,
so
yes.
In such scenario, we need a simulator which can tell us that these are the values required for link stability and all.
See, for pointing errors, if you want to that, here is your laser source. So here you need some kind of collimator or lenses to point your light in proper direction. So this pointing or to calculate this divergence, what is the angle of divergence these lights are making? For this, there is a very famous software, GMAX. So you using that software, you can calculate what will be the angle of divergence and how much it will diverge and all that. So you can do that using the GMAX software, but as far as this link and all that is concerned, you can do it with OptiSim. At the receiver, if the power level is in microwatt, then also it will work. Because we have seen it in our lab with a power level of I was given minus 18 dB. Then also I have received the signal minus see zero. Let's move to the next page. See, in my lab, I have received the signal in minus 18 dB. Then also I was able to receive the signal properly. So by minus 18 dB, minus 0 dBm, minus 0 dBm is 1 milliwatt. Minus 10 is 1 microwatt. So you can calculate it. It's like minus 18 will be somewhere like. So with this much less power also, we are able to capture the signal. So if you want to make a link length of 1 kilometer, it's depending upon the channel, how the channel is. So if you transmit power in, let's say in milliwatt, let's say you transmit a power of 2 milliwatt, or let's make it 2 dBm, then 3 dBm. Then if in channel of 1 kilometer, there may say loss of 10 dBm, then you will receive a minus 7 dBm of signal. So this will work properly. Then also it will work properly. So with this much amount of power, you can easily make a link of 1 kilometer. That is my understanding. What I have, what till now, what experiment I have done.
But sir,
Am I-
it will also depend on the modulation, right, sir? If we use higher modulation, then the power requirement will be much higher, as per my understanding.
So no modulation. It's also on the data rate what you are transmitting is.
Right, right, sir.
Higher modulation will improve the signal. It will be easy to transmit the signal at a larger data rate. So if you are transmitting a signal at a larger data rate, then obviously the power is much more required. In our lab, we are transmitting the signal at a data rate of 10 Gbps. So
And the modulation, sir, QAM.
okay,
Okay.
this is the basic modulation. So our kit perform this modulation only, on-off keying. NRZ is the data type and on-off keying is the modulation. So this is it.
Thank you. Thank you so much, sir.
Okay, thank you.